Hello and welcome to the EEPROM 9. Ooh, my big hairy hands. Yeah, they are rather hairy, aren't they? They look even more hairy on this camera with the particular lens I'm using. That's because it's the 50mm Super Takuma. So we have one of these, a MEGAMAN. No, not the MEGAMAN from the NES or SNES. No, these keep going pop. This is the second one now to go pop in my bathroom. Because what they use is like these GU10 up in the ceiling lights, and I think they're overheating, I'm not sure. But since it's died and no longer works, we might as well take it apart. And it's not the LEDs. In fact, I've had one of these and I took it apart and tested the LEDs, and they ran roughly about 40 volts from memory because I put them on my boost converter, but that's at the other end of the workshop, like a metre or two away, so that's a long way for me to walk and have to plug things in, and we're doing it on here, the confuser desk, where we seem to be doing a lot of camera maintenance lately and trying to restore. These Yakushir cameras are bastards to get working. This one, I've fixed the shutter and all that jazz, but the meter circuit doesn't work. I'm hoping I can just do a transfer and just rip out the meter from this one and stick it in that one, because this shutter mechanism is completely buggered beyond repair, certainly my level of repair. It needs spare parts. It needs a lot of work, and the shutter itself is seized because I tried lubing it up and it backfired. Live and learn. And the latest subject being fixed is a Fed 4, whose shutter, if we can get the light angled right, yeah, that's not a very happy looking shutter, is it? I would wind it on, but it's currently in a half dismantled state, so maybe he'll be subject to another video, I don't know. The actual curtain's fine, but it's the bands which hold it which just snap. Luckily these are fairly easy to get apart. Case in point, pop. Then what we do here is we just get a knife and snip it. So yeah, there's 5 LEDs. In fact, one of them... Was it this one or the other one? Hang on, let me just grab the LED chips. No, it's the other one where it was the LED chip that failed. Because here's the LED module out of the other one that's the exact same as this. And here's one that's like years and years old. You can see the white's gone all yellow, and it was actually an LED chip that failed, which got ripped off, and yeah, all that good jazz. They seem to roughly rely on about 3 chips each. I can't remember exactly what voltage it was. It was about 40 something volts to actually power them up. So we'll just move those to one side. We'll use a flathead to undo a Phillips screwdriver because we're just that kind of guy. A random screw can go there. So this one's going to be another case where it's actually the inverter circuit that's failed. And one of the things I hate about inverter circuits on these is they are... Okay. We'll just destroy the plastic. Ow. Have I just cut myself? It's about time I did. And my pliers aren't at this end of the office. So we'll just use brute force. I'm sure I'll cut myself open at this point. You get nice HD details of that. And then if we can do that, oh, we didn't need to undo the screw. We could have left him in place. So we'll pop him back in there. Because these are not very easy to solder to, thanks to the fact that this is aluminium, and aluminium is a great conductor of heat. Being a standard GU10, live and neutral do not matter a rat's ass. Ow! Where's my big pliers? Where's my big pliers gone? Where are they hiding? I seem to remember them sitting somewhere around here. Here they are. Then we use wire snippers, which we don't have down this end, so we'll just use standard Swiss Army knife scissors. And here we have a neat little circuit board, actually. That I should have an example, actually, that I can pull up with more detail. If he hasn't fallen off and gone to Timbuktu, which is, oh, there he is. So these aren't actually a switch mode power supply, they're a buck regulator, which are similar to switch mode in their topology, but work a bit differently and consist of a whole load of SMT. Let's see if we can get the, we should be able to get this to focus closer. Oh, you can see the aperture's stopped down. There we go. Give you a nice detailed view. So here we have the bridge rectifier, standard shenanigans. There's a diode, capacitor, standard stuff. So that's where the DC goes, and you can see there's no isolation. So you do not want to use these with the covers off, or you do risk getting an electric shock. Now the main power goes in through there. The trouble is it's very difficult to trace out. I definitely need to do that. Then we got a cap that's pretty much, yeah, it's across the live and neutral. You got a resistor acting as a fuse, because that's totally the best way of fusing something. It's the same on this. This is just your standard sort of 400 volt, 4.73, whatever the hell that, I hate that part numbering system. You've got what is most probably an inductor right here. In fact, the L0 designated marker on the board pretty much gives that away. You've got a transistor, who is a, I'm not sure which number is, but it's either the top, which is JW1792, and the bottom one is 7P1, no, L61CD. That could also be an I, but it's probably going to be a I rather than an L. Standard transformer, one pin goes to the output. In fact, the transformer is not actually a transformer, it's an inductor, because it only has 2 points of contact to the board. So yeah, this is proper inductor, boosty, convertery type layout here. You got a crappy, no-name brand 2.2 UF 400 volt capacitor, so mains voltage, apparently this is the main filter cap, all that usual jazz. One output here, the other output over here, actually at probably the negative end of the bridge rectifier. What does the marking say? Oh no, he's on the positive. Ha! That's a surprise. The actual boost part, this is a centre boost one. Negative boost one. That is unusual. Usually it's the positive ends they boost. It's the negative ends that is so-called grounded, or or to put it in more correct terminology, actually put on a common rail. So that's rather interesting. It's difficult to see what fails on these, but I should really get into investigating and checking all the components on these, because I swear, for guarantee, it will be a common failure mode. I guarantee it, these two boards will have the same failure mode. The annoying thing is there's about, well, a million other lamps, because the downstairs toilet uses the same system, and the kitchen does, as well as the bathroom. So these are going to continue popping like, well, balloons, for a better analogy. But yeah, that's pretty much that. A standard, pretty bare bones, simple, cheap and nasty LED lamp. Yeah, who said the old GU10s? Well, the old GU10... These are so bad, these pop at the same rate as the old halogen GU10s, which is really quite unacceptable, to be honest. Thanks for watching. So, yeah. MEGAMAN lights, don't buy these. They're crap.